Okay, let's start with question 1. We need to find out the reading on the vernier calipers. So step 1, we need to see what is on the main scale. On the main scale, we look at this number. What is this? 1.4. Okay. So this is 1.4 something cm. What is the something? We need to look at the vernier scale. Where do they coincide? Over here, 4. So you just put it in, 1.44 cm. Okay, that's vernier calipers, very easy. So answer A. Alright? Next question. The reading on the micrometer screw gauge. Now, this is different from the vernier calipers. Over here, what do you think this value is? 5.5. What about this? 6, 6.5, 7, 7.5. Okay, we are interested in this number. What else? What is this value here? 20, right? So the answer will be 7.5 plus 0.20. So what is the answer? 7.70. Answer D. Okay, those who don't have your paper, can you take out a foolscap and copy down? And if you are standing all the way at the back, you can't see, feel free to move forward. Alright? Next question 3. A pendulum, 30 seconds to complete 20 oscillations. What is the period of the pendulum? Period. What does that mean? Time for 1 oscillation. So, 20 oscillation takes 30 seconds. 1 oscillation takes 30 over 20, which is 1.5 seconds. C. Okay. Question 4. Okay, this is a measuring cylinder. The units are cubic centimeter. So this is the initial reading. How much is it? How much is this? 40. So, who 45? This is 40. Then after you put the solid A inside, the reading is now 45. That means volume is equals to 5 cubic centimeters. We are trying to find density. Density equals to mass over volume. Yes. Mass 20 grams. Volume 5 cubic centimeters. So you get 4 grams per cubic centimeter. Answer D. Next. This is a speed time graph. What can we tell from the speed time graph? Gradient equals to acceleration. Area under graph is equals to distance traveled. Okay, these are the 2 things you need to know. Now, which part of the graph has no acceleration? No acceleration means what? What is acceleration? Gradient. We are looking at gradient, right? Acceleration is gradient. So this tells us that gradient equals to 0. Where is gradient equals to 0? Yeah, C. It's a flat line. Okay? Flat, horizontal lines have 0 gradient. What else can we tell from this? When there is no acceleration, that means there is no change in speed. No change in speed means the speed is constant. We see from the graph, oh, the speed is increasing. Over here, the speed is constant. So we know C is also the answer. A few ways you can look at this question. Okay? A ball dropped from a height touches the ground in 2 seconds. Drop. So, initial speed, which I will call VI, initial speed, equals to 0. Time taken is 2. Acceleration is 10. Speed of the ball just before it hits the ground, that means they want the final speed, which we will call VF, final. Now, our formula is acceleration equals to final speed minus initial speed divided by time. Now we can substitute everything in, right? Acceleration is 10. Final speed, don't know, so VF, minus initial speed, 0, over 2 seconds. So, 2 times 10 equals to VF, which is VF equals to 20 meters per second. Okay? Kasha, okay? Speed time graph. Again, I'll write down what I always write. First, speed time graph, right? Gradient equals acceleration. Second, area under graph equals distance traveled. Okay, so which statement best describes the graph? Let's look at the first statement. The object is accelerating. This tells us that speed increases. Is it true? Is the speed increasing? Yes or no? See, this is your speed, right? So, for example, no, why it hang? Okay. For example, at time equals to 1, the speed is, let's call this A. I don't know what is it. At time equals to 2, what is the speed? B. At time equals to 3, what is the speed? C. Do you see that the speed is increasing? Yes, right? So, the object is accelerating. So this is correct. Answer is A. Let's look at why the rest are wrong. The object is decelerating. This tells me that speed decreases, which obviously is wrong. The object is not moving. Cannot be, if it is not moving, the speed must be 0. Which, in this case, is not equals to 0. And finally, it is traveling at constant speed. See, the speed is changing. Constant speed, it will look like this. Horizontal flat line. Okay, so this is also wrong. Answer A. Next, distance time graph. For your distance time graph, we know that the gradient equals to speed. Okay, straight line. Does it have a constant gradient? What is the steepness? Does it change? No, right? It's constant gradient, right? So this tells me that the speed equals to constant because the gradient doesn't change. Okay, which one is correct? The first one. Straight away we see that answer will be D. Uniform speed. Okay? Am I going too fast? Zafan, can you hear me? Question 9. Box, mass 2 kg, being pushed by 10 newtons. Then there is a frictional force, 4 newtons. There is an opposing force, 2 newtons. What is the direction of this frictional force? To the left or to the right? Why left? Junior, what do you think? Left or right? Left. Why? Okay. Let's think about it. Let's say there is no friction. What direction is this box going to move? If there is no friction, the box will move to the right because this is greater. So the box goes this way if there is no friction. Right? Now, friction will oppose motion because that's what friction does. It always tries to oppose motion. If you try to go to the right, it acts to the left. Okay? So we can conclude that friction is to the left. 4 newtons. Okay? So in this diagram, there are 3 forces. Number 1, number 2, and number 3. The resultant force will be 10 minus 2 minus 4 equals to 4 newtons to the right. Okay? B. Next, question 10. Magnitude of the force F and R. Oh, okay, read the question. Constant speed. Meaning what? No resultant, before that, no resultant acceleration. Resultant acceleration, no resultant acceleration, right? Therefore, we know that F resultant equals to mass times acceleration resultant. So if A equals to 0, so resultant force equals to mass times 0. Must be equals to 0. Right? No resultant force. That means the magnitude of error is equals to magnitude of F. The forces are balanced. That's why there is no change in speed. Okay. So what do we have? B. Next, mass 20 kilograms, falling acceleration. What's the force? Force resultant equals to mass times acceleration resultant. What is the mass? 20 kilograms. What is the acceleration? 10. Answer 200 newtons. Or when we have a mass that is falling down, the mass equals to 20 kg. What is the force acting on it? Gravitational force. What do we call it? We call it the weight also, right? The gravitational force acting on you is your weight. So W. What is the formula for weight? mg. mg. Right? What is this g over here? 10. That is also given in the question. So this is 10. This is 2. You still get the same thing. Wait. Same. Okay? Now we have another object, 5 kilograms. Gravitational field strength on the moon, 1.6 newtons per kilogram. On Earth is 10 newtons per kilogram. Which statement is correct? The object falls at the same acceleration on Earth and Moon. Obviously wrong, we said this so many times already. It falls faster on Earth, falls slower on Moon. It has different density. What is density? Mass over volume. Okay, on Earth and on the Moon, the mass same or different? Same. Volume same or different? Same. Density must be the same. So this is also wrong. The density doesn't change. Next, object has the same mass. Okay, we know that this is correct. C. And the weight, of course, is different. Okay? Which one is used to measure mass? Your beam balance is used to measure mass. This is used to measure weight. It is in newtons. And these two, you know lah, volume and over here, length. Okay, uniform beam, pivotal at the center. So 3 newtons, 4 newtons. What is the clockwise moment? Equals to clockwise, how much is it? Which force gives you a clockwise moment? 3 or 4? 4. Okay, this one brings it clockwise. So 4 times, what is the distance from the pivot? 0.1 Newton meter. Anti-clockwise moment equals to 3 times 0.1, 0.3 Newton meter. Is the clockwise moment equal to anti-clockwise moment? No, right? So is it in equilibrium? No, so it will rotate. How is it going to rotate? Clockwise, yes. So answer D. Answer is D. Okay, let's do this quickly. For ampere, the quantity is current. Temperature, the unit is Kelvin. Symbol, K. This is we are looking at SI unit. So we do not accept degrees Celsius or degrees Fahrenheit. We don't use this in SI units. Okay, we use Kelvin. Right? Let me try to do one last one. Deceleration. What is this? This is your negative acceleration. Okay. Now, acceleration, just how we did it, it is your final speed minus initial speed divided by time. So now we want to calculate what this is. let us substitute. What is our final speed from the graph? This is your initial speed. Final speed over here. What is this value? 0. This is your final speed. This is your time. This is your time. So substitute in minus 0 minus 12 over 5. And this gives us, what's 12 over 5? 2.4 meters per square second. It's 2.4. Okay? Does it make sense or not? Deceleration. It is going slower and slower. Right? In the graph, you see that the speed is dropping. So deceleration is 2.4. Okay? Next lesson, bring the same set, 2013 and 2014. Any questions? Okay, now you need to go for your cyber wellness